tell us about, first of all, tell us about the relationship between Midokura and Midonet, because I may have botched it up when I was introducing you, but is Midokura a company and then Midonet is the open source project? Did I get that right?
That's exactly right, and you did great. So actually, a lot of people use the pronunciation Midonet. I say Midonet. I'll just say because it's fun that Midokura comes from Japanese words mido, green, like Midori, and kura, which is an cloud in or sort of the technical cloud. So Midokura. And when the so it's correct, Midokura is the company, Midonet is the open source project, which we originally developed closed source, and we open sourced at the end of 2014. And I think there's a lot to talk about there in terms of how that sort of process goes and how things go when you take what was originally meant to be closed source and open source it, and the pain points there. But I think we'll get into that later on. So I'll tell you a little bit about the company and what we were trying to achieve, and then the open source project, and not just Midonet, but others, but one other in particular comes out of that. The founders of the company wanted to build a public cloud in Japan modeled on AWS. And so they got some seed funding, and they started to play with software and starting to think through their plans. And as they built their prototype cloud, they found that it was a pain. This was early 2010, and they were looking at all the cloud management software out there. So at the time, you had things like CloudStack. OpenStack was just getting started, and Nebula, Eucalyptus. And okay, try some of those out, and you say, okay, well, what do you need to start a cloud? And if you model on AWS and you want to start out with something similar, you're going to need object management right off the bat. So object management and block storage as well, so that you can move VMs around without losing their state. And the networking, of course, that you can isolate tenants from each other. So at the time, and I think things haven't changed that much, but at the time, the really big challenges in building your own cloud were storage, and you talked about software-defined storage earlier, and networking. So the founders scrapped their idea of running a public cloud and decided to focus on building software-defined networking for virtualized workloads. I can keep going, so just chime in, and I'll just sort of go on.
No, this is exactly what I was just going to ask you. Well, tell us about what the project is and what it does, and you're actually answering that question. So please keep going.
Okay, great. So this is now we're sort of still at the beginning. It's sort of mid 2010, and they have a prototype. And so what is the goal? Before we talk about I haven't said which platform or which platform, but what is virtualized workload? So at the time, really, containers didn't come into the picture. It's VMs. And so you look at what people are running in the data center. And I'm going to say, we talked about software-defined networking. It means a lot of things. We're focused on software-defined networking for the data center, and particularly for virtual workloads, because you can do software-defined WAN. If you want to go outside the data center, you can do software-defined fabrics, and there are lots of other products. But we really looked at sort of people running VMs, and even in systems. So look at a typical system, VMware. I don't know, 70% of the virtualization market. And what are they doing? They're running VLANs. And Jonathan, by the way, you did great. Great introduction to software-defined networking, because it's exactly as you said. So we run VMs. The VMs, for a long time, were just deployed as closely as possible to the way we were deploying servers. And that's not just in terms of, so you want the networking to work the same way, the storage to work the same way. But then what about the human processes? So you file a ticket to get a VM. You file a ticket to get the VM placed behind a load balancer, and so on. So even though you now virtualize your compute and your utilization is great, but you're still not agile. So one piece of that is, what's your flexibility in terms of how your networking is set up? How much interaction you have to have with the networking team? What components you have to deploy hardware or software into the network as you roll out new applications. So the goal was, from the very beginning, to allow the applications networking to be defined independently of the physical networking. That's the goal we set out with. So what does that mean? It means that you can, if you look at a picture of a data center and physical workloads, you have subnets, you have layer 2 networks, you have VLANs, but that's because you want to have isolation and segmentation of the layer 2 network. So let's ignore that from the application standpoint. You have layer 2 networks, they have subnets, you've got routing, you've got load balancers, you've got VPNs, you've got firewalls, and so on. So can we do all this independently of the physical network? Now, first, why would you want to do it independently of the physical network? Well, this is important because you eliminate the interactions with the network team. You simplify the physical network. The physical network shouldn't be changing as applications move around. Today, a container moves from point A to point B. The physical network doesn't need to change. And the same is true in infrastructure as a service, meaning virtual machine environments. So you simplify operations and you minimize points where your infrastructure will break. So we started out with a goal of just IP fabrics. That's all you need. Why? 2010, IP fabric is pretty easy to use. I mean, yes, you have to have network engineers that really know what they're doing, but you pick your vendor and people can keep IP networks up stable with quality of service. They can scale them. People started talking, I think the term CLOS fabric started coming up more and more. This is in around 2010, 2011. Everyone started to understand this idea of a spine and leaf. That's another term for a CLOS fabric. Essentially, you're creating a network with we talk about cross-section bandwidth, but basically how much traffic can you carry? And essentially, you're building a very big switch, but it's cheap because you're taking commodity switches and putting them together in a mesh. So this is not just your hub and spoke. This is a very dense mesh so that you have a lot of cross-section bandwidth.